Hi everyone, today we are going to learn how to find ladder elements in the given array. So what is ladder element? An element is a ladder if it is greater than all the elements to its right side, okay? And a right side element will be always ladder element. Suppose at line number 4 it is the given array. So right side element will be 2, so it will be always ladder element. So we can check for 17. So see, right side elements of 17 are 4, 3, 5, 2. So 17 is greater than all the elements to its right side. So 17 will be a ladder element. Now we can check for 16. So right side elements of 16 will be 17, 4, 3, 5, 2. So 17 is greater than 16. So and 17 appears right side of 16. So 16 won't be a ladder element, and 5 will be a ladder element because right side of 5 will be 2 only, and 5 is greater than 2. Okay, cool. So now we will see a approach how we can find out ladder elements in the given array. So like we can run through a loop I equal to 0 to I less than n will be a number of elements in the array. So we will have I index here. Now we need to check all the elements to the right side of 16, like 17, 4, 3, 5, 2. So what we can do, we can run another file loop, for loop. So we can have another for loop j equal to I plus 1, okay, to j less than n. So we will run this for another for loop. So here j will be here first. So see here, array of j will be, represent 17 and I will be here. So we will traverse through the whole array like this: 1, then 4, then 3, then 5, then 2. Then we will check 16 is greater than its right elements or not. Okay. So we will check for 16. Then see, array of j 17 is greater than 16. So 16 can't be a ladder element because 17 is appearing right side of 16 and E17 is greater than 16. So there is no need to traverse this whole array till the end, because we already know 16 can't be ladder element. So there is no meaning to traverse through 4 element, 3 element, 5 element, then 2 element. So we can have condition here: if array of I less than array of j, then we will break there itself. We will terminate this uh, nested for loop, inside for loop at line number 8. So we will directly come to line number 13. Then we will increment our I index. So I will be here. So automatically j will become I plus 1. So j will be here. So at line number 8, j will be I plus 1. So we will traverse through the rest of the array. So we will check for 17. 17 is uh, less than array of j or not. So see here, line number 9, 17 is less than 4. So this condition is false. So we will increment our j index. Then check for 3. So it is false. Then increment our j index for inside for loop. Then check for 5. Then increment our j index. Then check for 2. So at the end, j will become n minus 1. So if j equal to n minus 1, then we can print array of I as a ladder element. Ladder element. Okay. So we check for 17. So this loop will be terminated uh, because j will become uh, n minus 1. So j will be n minus 1. So we will come to line number 15 and we will increment our I index. So I will be here. So at line number 8, j will automatically become I plus 1. So we will check for 4. So we will check 4 is less than 3 or not. So 4 is not less than 3, so we will increment our j index, then we will check for 5. 4 less than 5, so it is true. So we will break our this inside j loop. So we will break this loop. So right now j will be 0 1 2 3 4 4, j will be 4, and n minus 1 is 5. So 4 equal to 5, this condition will also false. So we won't print uh, 4 as a ladder element. So we will come to line number 15 and we will increment our I index. So j will be here only. So at line number 9 we will check arrow of I less than arrow of j or not. So arrow of I is 3, arrow of j is 5. So 3 is less than 5. So we will break this inside loop, j loop. So here we will have arrow of I as 3 and arrow of j as 5. So right now j will be 4, j will be 4, and n minus 1 will be 5. So still it is false. This condition will be false. So we won't print 3 as a ladder element. So at line number 15 we will increment our I index. So I will be here and j will automatically come to 2 number, because see line number 8, j equal to I plus 1. For 5 we will check 5 is less than 2 or not. So this condition will be false. So here now j will become 5. So j will become 5. So we will terminate our this inside for loop. So we will come to line number 13. We will check 5, j will be 5 here. 5 equal to 5 or not? Yeah, it is true. So we will print 5 as a ladder element. True. Okay. So again we will increment our index and then it will be I will be here. So I will so j will be right now 6, and j should be always less than n. So and we have 6 elements in the array. So 6 less than 6, this condition will be false. So we will directly come to line number 13. So right now we will have value of j equal to 6. So j n minus 1 will be 5. So j, this one 5 equal to 6, it will be false. So our program won't print line number 14 as arrow 5 as a ladder element. So 2 won't be a ladder element according to our program, but we know last element in the array will be ladder element. So what we need to include here, we need to include here or condition. If I equal to n minus 1, then print arrow of I as a ladder element. So right now I will be here 5, and so right now I will be 5 to 5 and n minus 1 will be 5. So this condition will be true. This condition will true, and we will print the line number 14, and we will print array of 2 as a number 2 as a ladder element. So in this approach we applied nested for loop. So time complexity will be order of n square. So this approach is a dynamic approach. This approach will work with any given input, and it will work fine, but problem is we have time complexity as order of n square. We can find out a better approach where we can have time complexity as order of n. So we will try for another approach which has time complexity is order of n. Cool. So what we can do for another approach, we can traverse through the array. So like we can traverse through the array from last element n minus 1, okay, till I greater than equal to 0. Okay, because in array we have index start from 0 and end with n minus 1. Okay, cool. So we will start from last element and we will end with 0th index. We can have a variable to store the maximum element in the right side of the cell, this element. So right side max, we can have this variable and it will have value of n minus 1. So in this case it will be 2, and we will traversing this array from last index. So we can have this condition: if array of I greater than equal to greater than right side max, then we will print this array, given number as a ladder element. Okay, so print array of I as ladder element. So see, in this case array of I is 2 and right side max will be 2, so 2 greater than true, this condition will be false. So we can have or condition here: if I equal to n minus 1. So right now I will be n minus 1, so we will directly print line number 10. Cool. So we have I and we have arrow of I, we have right side max also, we have this condition also, this line number 9 condition, and we will print here ladder elements. Cool. So initially I will be n minus 1 index, which is 0 1 2 3 4 5. So I will be at 5 index, so arrow of I will be 2, right side max will be 2. So this condition will be false, 2 less than 2, 2 less than 2, this condition will be false. And we have or another condition which is or to this condition. So I equal to n minus 1, so it will be true, it will be true. So we will print line number 10. So arrow of I 2 will be printed as a ladder element, so we will decrement our I index. Okay, so I will become 4 here, so we will have 4, then arrow of, so see line number 5, we will decrement our I index, so we will have arrow of I as 5 and right side max will be 2 only. So we will check 5 less than 2 or not. We will check arrow of I is 5 greater than, here should be greater than, arrow of I greater than right side max, so right side max is 2, so this condition is true. So in our condition, if first condition is true, then we won't check second condition, so this condition won't be executed. So we will print 5 as a ladder element and I, so I will become 3, so we will decrease I. But see here, for number 3 we have right side elements as 5 and 2, see line number 4. So right side max will be 5, so we need to update our right side max. So in this if condition we will update our right side max. So right side max will be array of I. Cool. So here we are updating, so I will write here so here it will become 5. Cool. So right now we have ith index as 3, arrow 5 will be 3 only, right side max will be 5. So we have arrow 5 greater than right side max, so 3 greater than 5, which is false. And first condition is false, so we will check for second condition. So 3 equal to 5, this condition is also false, so we won't print this ladder element. So line number 11 and 10 won't be executed because this condition is false at line number 9. So we will just decrement our I index. So we will decrement our I index, so it will become 2. I think right max should be before decrementing I index. It should be before, because it will be executed at line number 11, and this one decrementing of I will be executed at the end of this loop, line number 13. Cool. So we have 2 here, and here it was 3, ladder element was 5. Cool. So 3 equal to 5, it is false. So we will decrement our I index. So I index will become 2. So we will have 2 here, and array of I will be 4. So we need to decrement here also. So it will be 4. It will be 4. Still right max will be 5. So we will check 4 is greater than 5 or not. So this condition is also false. Then we will check for or condition for 2 equal to 5. Right now in I will be 2. So we won't print ladder element, and we won't update right side max. Line number 10 and 11 won't be executed. At line number 13 we will decrement our I index. So it will become 1. So we will have I as 1, and we have arrow of I as 17. Arrow of 1 will be 17, and right side max will be 5. So we will check this condition, 17 greater than 5. Yes, it is greater than 5. So this condition is true. So we want to check or condition. Okay. So at line number 9 this whole condition is true. So we will execute line number 11 and 10. So first we will execute line number 10, and we will print our 17 as a ladder element, and we will update our ladder element. See line number 11. So ladder sorry, I mean right side max will become 17. We will update our right side max, and we will at line number 12 we will decrement our ith index. So I index will become 0. So I index is 0, and array of I will be 16. Right side max will be 17. See here at line number 20 we have updated our right side index. So we will check 16 is greater than 17 or not. It is not. So condition is false. So we will check for index 0 equal to 5. It is also false. So line number 9, this if condition is false, so we won't execute line number 10 and 11. We will just increment our ith index. So ith index will become -1. So we will have I will be -1 here. So see at line number 8 we have this condition, I should be greater than equal to 0. So right now I is -1. So -1 greater than equal to 0. So this condition is false. So we will terminate our this for loop. Okay. So it should be here. So we have traversed through this array, and we have printed our ladder elements. So ladder elements are 2, see line number 16, then 17, 5, then line number 20, 17. 2, 5, 17 are the ladder elements. Cool. So now we are going to write a C program for this approach. Okay, cool. So I will comment this code, and I will write C program. So this approach is commented by multiple line comment. Okay, cool. Now I will write C program. Cool. So for C program, first I need to include our header files. So standard input output dot h, then int main method, then main method is a integer type. So we will return integer value here, which is we can return 0 here. So we will have int n. So I will have here 6 for the given example, but you can provide input through scanf. So user will provide input and then you can fill values in the array. So I will have here 6 equal to, so here it will be n only, and given array will be this. Okay, cool. Then semicolon, then I will have a variable I, then I will have a variable right side max. So initially it will be array of n minus 1. Cool. Then I will run a for loop for I equal to 0 to I equal to n minus 1 to I less than I greater than equal to 0. Then I will decrement my I index. Cool. So we will have if condition inside this for loop. If array of I greater than right side max or I equal to n minus 1, then we will print this element as a ladder element. So printf, we will have percentage %d so it will print ladder elements array of I. Cool. So we need to update our right max also. So we will update our right max here equal to array of I. Cool. So we can have print statement here, printf ladder elements are okay, or we can write like this, and it will print, and yeah, we have done. So now we will run this program and we will see the output. Okay, cool. Program and we will see the output. See, it is printing ladder elements are 2, 5, 17. So it's a dynamic program, like we can change our given input and we can see the output. Okay, like we will change our given input as 13. So 13 will be a ladder element, 13 should be printed. Here we can have 12, so 5 won't be a ladder element. So ladder element for this input will be 12, 13 and 17. Okay, cool. So now I will run C 12, 13, 17. So it's a dynamic program, it will work for any given input. So for this program, time complexity will be order of n. Okay, because we are traversing this area only once, and space complexity will be order of 1, because like we haven't created any new array, only we have used variables like right side max and I and n variable. Okay, so it will be 1 only. order of 1. Begin write order of 1 also, and it will be m. So what I will do, I will provide a link in the video description. From there you can get this source code. Okay, cool, thank you.